Just
Sure.
I will do that. Fine. So you can see that this is an export which will happen. If you want to see the exact command on the cloud, you can try whatever Aditi and Gaush have given. You can also try with that. It's exactly same. It's just that you need to add the hyphen driver, give the appropriate address for your cloud environment, and that should work. Now, what I'm going to do in the starting itself, I'm going to start with a case study. We have still to do scoop jobs. I will bring that also after this. But let's start with a case study so that we get an insight that how this whole thing is going to work for us. So for today's session, since we have just first case study, so maybe this case study, let's do it all together. From the next case study, which is going to come for Apache Hive also, I'm going to split you into groups and that you can do it because that will be more sort of, you can say that this is going to be designed with a business objective or something. This case study is more related to Enrun framework. So I don't know how many of you are aware of this already. So there is something called as Enrun. And basically what happened was that company kind of had a problem like after there some email got leaked and they got bankrupted. How many of you people have heard their story? ENRON, that's the company name. If you want, you can also check their data. Let me show you. So this company sort of got bankrupted. Uh, and basically a lot of emails went public for them. So we have all their basically data with us now. So this is the one. It got collapsed in 2001. Can you all see this browser? Right? So you can see that when Enron collapsed in 2001, about 500,000 internal mails were made public. So there were already some publications based on the data. So what we're going to do is, this is all the data set what they had. We had an employee list, we have a message, we have a recipient info, and we have a reference info. So all this info is there. It's just that this data was not clean at all. So what I have done basically here, I have collected all these 4 files and I did some changes into it. Number one, I removed some column constraint because that was sort of going to impact in my scoop. Definitely, I have not removed the primary key because that was required. Second was I made sure that the data types are valid because the data types were not actually okay when I downloaded this data. Third thing was that there were some places where it was single inverted comma close. That's it. So there was no null. Instead of null, it was written as single inverted like space sort of character. So that I have sort of replaced with null. And even I have also replaced the single insert command for basically making the multiple records. That you can ignore because that's something I have done it for myself, just to quickly insert the data into the new table because I've sort of created a new table from that after cleaning this up. So I have already got this data ready because I don't want to get all the time being wasted in the session itself. Though it's a good practice and generally data engineers do that, sort of do the data cleanings and all that aspect. So I have already got that also uploaded into your lab as well. So all this data set is already available for you. Can you all quickly go ahead to your lab and just say select extract from employee list? Then just tell me whether you are able to view this data or not. So you have to hit it for all these 4.
Yeah, sure. We can see.
You can see that. Just see the schema. Can you see the same schema? EID, first name, last name, email ID, email 2, email 3, email 4, folder, status, right? Similarly, if you look at message, I have renamed it to message new. So you can say message new and it should return because actually there were a lot of changes into this file. That's the reason I have done this change. Can you all just type select extract from message new? I want to just confirm whether we have all the 4 tables got inputted properly or not. maybe just write limit 5 or something so that you have to just see the initial 4 5 rows. Otherwise, it will start printing everything for you.
Is it message underscore new?
Mhm.
Um, in Learn Deck, I cannot see that. I can just see it as message.
The file name is by message. That should also
Yeah.
be fine. Are you able to see the same
Table name,
columns? Like
table name is message.
that should be fine then. I think while importing, I might have the file name I have actually used a message new. I think I might have changed it just recently. That's fine. Column names the same, which is message ID, sender, date, message underscore ID, subject, body, folder. Can everybody read?
Yeah. The last one is message folder. That's it. Uh, and everything else, the column names are there.
Correct. Correct. Then can you also look at the recipient info? Guys, just all of you have to do this because otherwise, when you will start working on the case study, you will not know. I would also suggest take a pen and paper and note down all these names as well, so that you remember it. That you have to work on all these 4 5 tables.
How to stop this Shivank control C or control Z because I'm not given the limit.
Uh, Sorry, which you want to stop what?
Message it is continuously running.
Okay, so you have to say I think Control Z.
Okay.
Yeah, so better to use limit for all these things because it's a very huge data. Have you all checked that? Let me know once you can see this as well, and note down the name of this table as well along. If you want, I can give you this link so that you have at least all the schema info with you. I've also given you the link just to kind of have the schema info and the table name with you.
There's an extra column in recipient info.
That's okay, which I have added just for
Okay.
some more extra things. Basically, I've written a script to add or delete or modify a few things. So initially, I was thinking to actually have all this in the raw format and then ask you to even clean it. But then I thought about your background. I'm not sure whether you are good with that data cleaning aspect. That's the reason I did that before itself. But definitely, if you are a data engineer, then do all these steps on your own. Maybe you can download this raw data from here, and after today class, you can try that. Okay, what about reference info? Can you confirm?
Yeah, we can able to see.
Okay, you can see that. Awesome. So now let's start. The first thing. Okay. So there will be 5 6 problem statements which I'm going to give you, which will also include some portion of your optimizations as well. So one thing which I want to just tell you, and I think all of you are well aware of this as well. When you work on a project, so right now what is happening? You are in a learning phase, right? In learning phase, generally what happens that even doesn't matter how deep you go, but there will be a lot of things still in that topic. Like we can keep talking about Scoop having so many stuff as well. Then when you go to your project phase, you know your background, everything up, but there will be still at few places something will keep on coming up for you. So the challenge would be that when you're working across with respect to your project, then the challenge majorly start that maybe one or two parameters will be new, which you need to catch up because depending on some problem, and that you may have to read either documentation or Google to kind of fix it up. That is the main intention of this right now, to bring up few of the event situations where you may have to still look out a bit. I will anyway be there to help you out immediately, but just to give you that insight also that how you will be looking out. First thing first. Uh, so let's say you started importing the data for employee list. Okay. Can you all go ahead and import this data? Maybe use a warehouse or whatever you want, and tell me what is one of the major issue you are watching there. Everybody clear on the problem statement? That's the first thing to start with. Import the employee list. You have to tell me what is the major issue you are watching there. After that, you have to fix it as well. But let's talk one by one step. So fix the first portion of importing. Looking at the size of that, you have to also tell me the size, what is coming in the SDFS. And at the same time, I'm also interested in finding out what is the issue in this.
Shivang, for me, it ran successfully and data also imported successfully.
It will run successfully, which is perfectly fine. I have not given you anything which will run. If I would have given you the raw data, then there could be small, but it will run. Now, after going in, tell me what's the issue in that. Let's say the client gave you this data, you cleaned it. Well, maybe the cleaning part was done by some architect and you got a good amount of data. Now, basically you have to do some operation. The first step was to import it in SDFS, and after that only you can start any operation. So will you just import it and start working on it, or will you try to find out some issue? I'm already telling you there is an issue inside that. So that is what I want you to watch.
Uh, One of the issue is the headers of the file is not coming.
So that is not an issue, let's say. Headers is fine, ignore it.
So Shivang, you want us to go through the contents of the table and then find the issue. What is the issue with the data?
So like I just explained you the problem, Karthik, right? Everyone just listen to me once again. So let's say your client gave you this data. Maybe on this data, you may have to do some analysis further. Maybe it could be anything. You may want to put it into your Spark and do some machine learning on it or whatever, right? You want to apply it. So as soon as you get the data from this RDBMS table, are you immediately going to start working on it, or you're going to see that yes, there could be some issues here, possible issues which you would like to identify right away? I want it to be maybe more of a discussion forum. So maybe even I would like it to be more open, the discussion among yourself as well. I will also keep contributing in middle. So whatever thoughts are coming, can you start talking on that?
So the first thing I'm seeing here is there are many null values in the table. So
Awesome.
maybe we have to handle those values.
Awesome. That's a very good thought. I'm really happy that Karthik came up with this. So there are a lot of null values which is sitting inside your RDBMS. Now, except Karthik, since Karthik have brought it up, so I don't want this answer from Karthik anymore. Can anybody else tell me that from null, when it came to scoop, what exactly happened? What exactly happened here? Yes, Aditi.
Became string null.
It became string null. Okay, very good. So I want answer from somebody else now other than Aditi. So what's the problem with this? If you're saving it like this, is there any challenge with that? So what Aditi and Karthik said is completely right. I'm just repeating it up. In my RDBMS, I have some null data. What Scoop do is it also brings those null data as a null string in Scoop. It encodes it in this format, which is all fine. So which you can all see in your SDFS file. Now the question is, what's the problem with this?
I consider it as an empty.
Consider it as empty, but if you know the AI side of the things, maybe this null, I can anyway remove it easily, right? So what's the challenge, Banju? Any answer? Arun, what's your thought? Yeah. Arun, you want to speak up?
How about when we export it?
Okay, that's a nice thought. Anything else?
While exporting, it has come as string values.
Okay, that's a nice thought. Good catch, Arun. Good catch, Manju. Any other problem? Gaush? Any answer from your side?
Mostly when we see this data, like it is primary email, secondary email, and third email. The only column is having null values is the secondary and second and third email. So if we lose that data also, no problem with that.
Abhishek, any thought from your side?
Mm, Not sure about it.
Just
I
give
think we can't use for aggregation functions now. there it will give problem.
Okay. Let me give you the right answer. Though few of you have given the perfect answer. Wherever they said it's the right answer, it means that was correct. Definitely while exporting, that will be a problem. Actually, if we look closely in this data set, some of the rows have actual null value sitting in the string. Means, let's say there's a column name. Maybe the name within that column, there is a name written as null. Okay. Now, can anybody tell me what will be the problem now?
It considered as a null as a name, not a value. I mean, like not empty.
Correct. So by chance, if you decided from some other data science or some tools to remove this null, you will also remove the genuine data also. So that will become a problem. And in this data set, this problem is there a lot. That's the reason I extensively bring this problem. So what we should do in this case then? Should I bring the data and then do some operation? Or should I do it with the help of scoop itself now? We should stop this problem at the scoop level itself. What we should do?
Yes, while importing itself, we need to convert those null values to empty strings and we need to pass.
I want you to, now you understood the problem. You have got basically to a good resolution that, okay, we have to do something for these null values for using my scoop itself. Now, can you go ahead and tell me how scoop can help me with this? You can use Google. Feel free to use Google now for this. Before you even go for it, let me ask you one question. Which all column in this table have this missing data problem? Have anybody identified those column names yet?
Email 3, email 4.
Okay, that's the right answer. What are the names for it?
Email underscore 3, email underscore 4. Sorry, not underscore 4, 3 and 4.
Shivank, I even see a null in the email too.
You didn't see a null?
Yes. Yes.
I see a null in email too as well.
Email too. Actually, that null which you're seeing in email is correct one. So that is supposed to come like a null only. So yeah,
Okay.
I tell you that I can give you the answer. So this is ID column, one will be your name column, and one will be your address column. You can check it out. Okay. Now one thing here is, what is the data type of ID, guys? What is the data type for this?
Int.
Can I say number? Okay.
Yeah.
What is the data type for these two?
String.
String.
Definitely, when I'm going to deal for these columns, basically in my scoop, then I have to deal differently, right? Because this is a numeric column, this is a string column. So I gave you already a very big hint. Now, can you go to Google and search it and give me the exact parameters we need to use to fix it?
We can pass some parameters.
What?
Input null string as /n and non-null string as something.
So can you tell me what you mean by here when you say null non-string? Means what's basically the difference in them?
Whichever is system null is null non-string.
Whichever is?
System null, like capital NULL.
Not exactly. Think about it again. I just talked about data types. So definitely it should be related something to data types also.
It's a null data type, null or none, what we say. It can have only that value.
Okay. Okay. Anybody else? So Aditi have closed in fact, she have given a very close answer, though not fully hit the nail yet, but she have given a close answer. So with respect to that, would anybody would like to add something more to her?
So, Shivang, is it something like a replacement for a null value which comes for a string or non-string columns?
Correct. This is what we have to do. So what I'm not asking you to right now execute any code. What I'm looking for an answer right now, that what do you think we will be doing with it? I think Aditi have already given that answer. What I'm now looking for it is that can you tell me that what these things do? Like she introduced two terms right now in front of us. So in basically with respect to these two terms, what exactly we will be doing here? That's basically a question. The two terms I can also note it down for you. What she introduced is one is we should be using hyphen null non-string, and the second one was she introduced hyphen null string, which is perfectly fine with me. But tell me how this is going to help, what these two are doing here.
We can tell, like how Surbhi told, we can pass these parameters and give some value to be replaced. Okay. In case there is a string, if there is a string null, then we can use hyphen null string and give whatever replacement value we want for it.
Perfect. That's very good. So basically what it will do is whichever column is going to be my string column. And in that string column, if it finds a null, what this will do is this will tell me that, okay, go ahead and replace that null with whatever I want. For example, I can say after that NA. So it will replace everywhere wherever the missing data is there in RDBMS with a NA string here. Then similarly, if basically I have, let's say, some situation where I have a non-string, like, which is like integer ID column, then in that case, it will automatically go and replace that with whatever you want to replace with. Okay, let's say you want to replace with /n. Now /n is a special character, so you need to use one more backslash and then close it with this. So that will happen in this case. Now with this, it will take care of both the scenarios, whether it's a string type of thing or a non-string type of things. So it will take care of both the scenarios. Everyone clear on this part? Now, can you go ahead and write this code? All of you. Fix it using a scoop query. If anyone face problem, please ask me immediately.
I'm getting the error illegal escape character.
Then
Flash W.
right? Whether you have special character, if yes, then use a backslash on this. Just a hint for you.
Hello. Sorry.
If you have us using a special character or something, if yes, go ahead and remove them out. I just gave you a hint how to solve it. Anyway, we're just gonna propose a solution in front of you, but before that, I want you to try.
It is running now.
Running fine. You are
Yes.
able to see now the one.
Yeah. It is still running.
Okay.
Yes. Done. Done.
So what was the mistake you have done, Ramnath?
I put only one slash. Backslash.
Okay. Once it's complete, tell me, first of all, whether when you go to your data set, you are able to see that change. Secondly, what's the size of the data? Because we will be using it further for some optimization discussion.
First it was 12.9 kbs and now it is 12.4.
12.4 KB per file.
Total, I just added up all the 4 files.
Okay. So total is coming to 12.4 KB. Okay.
Right now, before it was 12.9.
Okay. So at KB level itself, when you're seeing this small change, imagine what will happen in the terabyte level. Okay, have everyone completed this now? Take 2 more minutes. Done. Let me show you the command now. How we can do this. So guys, and I need your attention now on this. I can show you the command. I think all of you must have already done it. In case if it is not done, you can see this now here. So you can see this here. So the way we will do it is we will use the same scoop import. We will use the connection string, username, password, table. Look at this. Hyphen hyphen null string. So whichever column have the missing data, replace it with NA. If null non-string, which means like columns which are numeric, in that case, it will replace it with /n and then hyphen hyphen warehouse dir and define whatever location you have. I'm not executing it because it takes a lot of time, but this is the way you will be executing that. So you have to just add these two parameters. One is hyphen apple null string. Second is hyphen apple null non-string. I think Aditi, you brought up that email column you're also watching as string, some missing data. So if that is a genuine one, it will not basically remove it. If it is a null character, it will go ahead and remove that because here we are not telling any specific name, right?
Okay.
But there it was a genuine case. So that's the reason it will not remove it. Now, second question, which I want to give you is related to little bit of optimization. I am going to divide the class into two parts for this. People whose names are starting from A to G will be working on a different basically table, and people whose names are starting from basically after G to Z, they will be working on a different table. So let me tell you both the table names. So one is people starting from A to G will be working on a table called as recipient info. Okay, and people who are basically having a different one, they will be working on a different one. Basically that will be message. Now what is the exercise you both gonna do with it? We are gonna identify the optimal number of mapper in this case. So what I want the value is, generally we don't know. By default, what happens is the number of mappers goes by default as 4, right? But what happens is we have to still find an optimal number to hit it across a lot of times, because we may have to, let's say, import the data multiple times, not just once, multiple times. So what we generally do in these cases, we start with some number. Let's say we say, hey, let's start with 3, then let's go to 6, then maybe also try for 4. Randomly we are trying, maybe we try with 10. So I want you to try with this just 4, because it will otherwise take a lot of time for you to do that if we have to do for all the things. So maybe you can try with 3, 6, maybe if you want you can add 5 also to it. Run your scoop code continuously on this, or maybe just remove 3 and 6, maybe just run it for 4, 10 and 5, so that we can be quick. Now what I want you to do with this, try for these two different tables and tell me which one is working the best. Means not just in terms of time you need to monitor this. So one way is that we look at the time. We never have to look at this the time. We have to also see one more thing. Notice when your mapper is running, you will find something like this. There will be some date written here. Let's say 18 something something, right? Then there will be some time written here, 0, 13 something. Then after that, it will be written as info. It will be written as mapreduce.import job base or something. Then after that, it will be written as transferred. Some MB of data, let's say 90 MB of data, something like that, in 36.22 seconds, something like that, it will be written. And then in the bracket, it will be coming up like, it will be something like 2.4865 MB per second. Right? This is what interests us. What basically is the way we are looking at this transfer speeds. Okay. So let's say if I compare that with mapper is equal to 10, mapper is equal to 4, mapper is equal to 5, how this is moving up. Can you all try that quickly and tell me for A to G and people after H to the last, means especially S people, I think with the name, you have to work on the message. Tell me what's your observation. And just to give you the command, okay, no problem, Girish, that's fine. So if you want to remove it, either you can say -m, give the number of mappers, or you could have also used -num mappers and give your number, let's say 10. Right? So anything is fine. Main thing here is to look at the optimization perspective.
So guys, I have run it for 10 mappers, and I've got the info which Abhishek Shivank was asking. So it is giving 240 KB per second, and total time taken was 30 seconds.
Okay. So if I ask you which is working better, means lower mapper or a higher mapper?
Yeah, let me check for others also. Maybe someone else from the group has done with 4 or 5.
Okay. You can also try that.
I did for 5
I did for
for
4.
recipient info table.
For 4, for me it got 6.72 MB per second in 23 seconds. And the transfer rate is 294.55 KB per second.
Can you all discuss among yourself and give me a final conclusion? You can use the chat box. You can unmute yourself and can talk. Anything is fine. And people from after H starting their name.
Started from message. It's for 4. It took like 7 seconds.
So I need an inference. Maybe somebody have to act like a lead here. And if you can come up with some inference from it. So I can assign maybe 1 or 2 from here like that. Maybe Ramnath, you have to take a lead for your group. Maybe from here, Aditi, you have to take the lead for your group and give me a final inference. You guys can also use the chat box to discuss.
Shivanka, I've pinged you the error I'm getting.
This is considered a message that already exists. Just rename some the name which you are giving in the command.
Yeah, I already did that. I renamed earlier. I was running it for -m6. Now tried different folder message_map6. Earlier I was trying for 4. That also gave the same error.
No, this is not related to number of mappers error. This is basically when you're storing it, right? Maybe you have already run sometime. You have already created a file, and then after that you again rerun with the same name. Maybe that could be a target dir, it could be a warehouse dir, and that's where your error is coming, that it already exists.
Okay.
So just change this target dir or warehouse dir, whatever you're using, and then see the result and let me know.
Yeah.
I can see a lot of discussions happening in group A. Ram, whatever you would write something in message. Aditi, can you infer from your answers whatever you guys are discussing?
Yeah, just trying to put everything in
a
one table
little
so that we can.
I A to G group. I didn't realize I was in next group. So I was doing for recipient in info whole thing.
Okay, can you do that, Karthik, for group 2? Yeah, Aditi was saying something.
Just putting everything into a table so that it's easier to compare. Just give us some.
Sure. So guys, you have just next 5 more minutes to complete this. Guys, what I am mainly interested here in to see that whether increasing the number of mappers is always helping or not. And secondly, how we determine where to stop. Is there a landmark? We have some ways to look at this transfer speed to say that, hey, it looks like this seems to be an optimal number. Okay, so Aditi, you have shared this. Can you infer? Maybe Aditi and Arun, you two together can infer whatever. Karthik, Ram, I'm waiting for your response also. Last 1 minute only. Meanwhile, group one, can you answer that?
I think you want to take a crack at it?
You can also mention Arun.
So yeah, what I'm saying is the amount of the difference between 4, 5, 6, and 7 and 8, whatever is minimal. I've seen from 3 to 4, there's a lot of increase. It jumped from, for me, it jumped from about 233 KB per second to 315 KB, 315 KB. And going to M10, it dropped again below 300. It was about 337 or so. But the gain I've seen from the change from 3 to 4 is significant. It jumped from 233 to 315 KB per second. After that, the change increment was less. So for M4 to M6, it increased like maybe 315 to 316 or so. So I'm thinking 4 would be optimal. That's what I think.
Okay, Aditi, what's your answer on this?
I want to agree with Arun. So as far as I saw, the difference between when we checked the difference, there was more difference between when we went to M4, but after that, there was not much of a significant difference.
Okay. So a question, why you guys have not gone for M is equal to 7, which looks like 360?
Actually, there is some difference there. If you see between Gauss and my answer, I was just checking Gauss's answer. He had 265. So we were just discussing the same thing, Gauss and I, like, why is there a huge difference between his values and my values?
Okay. That could happen because you're working on a cluster. And sometimes that time, remember we discussed about that, how these things work internally. There's a lot of requests go to master node. Maybe master node got busy in a lot of other activity and it must have added to your time. Generally, when you're working on a bigger data sort of situation, then the difference will be very low.
So to add up to the Aditi's point, I got disconnected in between the meeting, but I was also thinking like 7 was having optimal transfer rate. But now when I run it on my machine, I am also getting very lesser value. You can say 158 KB per second. That's it.
So now what you can kind of derive from it that the data set which are sort of in the size range of the table you have run, for those kind of table, maybe this might be an optimal transfer speed or this might be an optimal number of mappers we can go with. So this gives you this insight. If you look at the message table, that is a complete different size table. Anybody who have done this? Karthik, in fact, have you done it? I can see Manju have done it.
Yeah, Shiva.
Yeah. So can you tell me what's from that?
Yeah, first while I'm checking for it, it was like 43 seconds for 4 mappers. The size was 128 kbs, and then it will be increasing to when I'm move to 8, it was 303 kb per seconds. Then I directly go with the 15 mappers. Then it was very increasing, and it is. I think it took more time. So minimum, like minimal is like 4 is better.
Okay. So this gives us a lesson that it's not that always increasing the number of mapper will. Actually, both these data sets were not very huge. But if you have a smaller data, in that case, if you increase the number of mapper, the challenge would be you will see the slowness in your response. But if you have a very huge data set, then in that case, it makes sense to keep on increasing the number of mappers and see that with optimal rate sort of hits for me. So this is the way we will be sort of. One more thing which I want to, so everyone clear on this part, right? Before I go to the next problem.
So quick question, Shiva. So is there a guideline on, so you said if it's a huge data set, then there is a reason that you could probably deploy more mappers. Is there a guideline for that, or is it just trial and error?
No, there's no as such any official guideline for that. But this is something which I have myself observed while working on these data sets.
Okay.
Okay. Now,
Shivang, when I am observed here, only mappers is showing the percentage. Reducers, it's always showing 0 only.
Because there's no reducer, right? We discussed that when we work in Scoop, we need to do any aggregate, Manju?
No, but okay.
So it's just a copy paste. So mapper is enough to handle and finish the task for it. Okay. So we have 4 different kind of data file format with us. One is a text file format. Second is XML or JSON file format. Third is a sequence file format. And the fourth is a Avro file format. When we talk about CSV, I think everyone is well versed with it. This is, I think we have also used it a lot. It being used very extensively, but it have a very limited support. Like you cannot basically from the schema evolution perspective, and even you cannot have the block compressions, which you can also apply for it. So it's not very compact. It takes more space as well. So it's not that great when it comes to the compression and the compaction. On the other hand, if I talk about XML and JSON, though it looks good, you can define rules, it's machine readable, human readable, it's like a key value pair, what you can define. Everything looks good, right? But if you want to split this data, it's a little tricky. So in terms of when you talk in terms of the parallelism, that's where sometimes the challenges comes with it. It doesn't mean you cannot do it, but it do takes time. Second thing is, again, your block compression are not going to be impacted. So again, you will not be able to have, because a lot of times we have like zettabytes of data or petabytes of data, which you would definitely like to little bit keep in a compressed formats. So that is again going to be one thing. So splitting is going to be tricky and it cannot be easily split. Since it's not easily splittable, that's the reason the parallelism in Hadoop will go for a hit. Coming to the sequence file, think of them like a binary file. Okay, we keep it again in a key value format, but again, it's going to be a binary key value format. One more thing about it, since we are keeping it in a binary format, so they are going to be more compact than any of your text file or the JSON files. Because you're just keeping your data in a binary file, right? And each byte, if you know about it from the normal computer science, it could have almost 256 possible values then because of ASCII. If you look at ASCII, I think that have 128. But here, since it's the binary format, it will have 256 values. So it's almost, you can say that it's almost double, right? In terms of compaction now. In your text format, we use ASCII. And here it's binary, right? So just keep that in mind. That's the reason 128 to 256 is a double number as such. So it do support the block compression and you can easily split the file. So you can easily process it in parallel as well. So this is widely used, I would say, in your MapReduce jobs. Even in Spark programming also, you might be using SQL files a lot. Fourth format is an Avro format. This is more of a language neutral sort of uh, data serialization system, you can say. So I hope everybody is sort of aware of what is a serialization. Like it could be like easily kind of transmitted over the network, and we keep it again into the sort of the binary format only. So here, so what we are doing is you can think of it just like a process of you can twin your data structure into some format that can be easily used for storage, or you can transmit it over the network. Again, it's going to be language neutral, like I said, and it can be easily read anytime later as well. Even if you are using it from a different languages, it's completely fine. It's very easy to read even from that, and it's very much self-describing, and you can easily compress it, you can split it, and again, because of these reasons, you can easily parallelize them. And since you can parallelize them, it is again a very good format to be used for your project as well. Again, since these are the binary files, hence they are again going to be the compact format, then your text format, and it also kind of support the schema evaluation. Now, what I mean by the schema evaluation here is that schema which you have used to read the file, it doesn't have to mandatorily match with the schema when you have written the file. So it could be a different schema as well. So that's one of the best thing across which comes with it. Now, so you will also notice when we will save this, so you can easily make out that these two formats are quite better in comparison to what the formats we have till now used. That's the reason in your projects also you will be finding that. So now the next exercise which I want all of you to do is, can you, the text file we have already done it. Now the same command you have to hit. Let's say if you have changed that -hyphen null string, keep the same thing. Convert it to a sequence, convert the second, again hit it and convert it to Avro. So you will get three sizes. Tell me all the three sizes, which is more compressed right now. So this is what I want you to basically kind of perform right now. You can take any table of your wish. I'm completely fine with that. But I need basically the answer with respect to the formats. If you want, you can also use reference info because we have not yet played with that and it's a little bigger table. So maybe you can try with reference info and tell me that with reference info, try with a text format, try with a sequence format, try with an Avro format. And let me tell you, it's very simple to do that. If you want to use the sequence format, just add a parameter ---- as sequence file. If you want to do Avro format, just add ---- as Avro data file. Okay, just add that and let me know.
We have to use reference.
First recipient. Though you can use any, but since it's a bigger file.
Okay.
So just to give you the idea, we have saved almost millions of amount of money by just changing the formats into the projects. This has so much of high impact. And even the performance have drastically improved.
So Shivank, I have imported as all three formats.
Okay, so what's the result? Sorry, I was talking on mute.
So there is not much difference in file size. It is coming like for text 15.9 MB, then sequence 16.1 MB, and for Avro again 15.9 MB. But the difference which I see is the amount of time it is taking to import. So text file is taking maximum time, like 38 seconds. And KB per second is also very low, for some around 420. And this sequence file is taking least time, 25 seconds, and the rate is 640 KB per second.
Okay, that's pretty good. I will tell you just one more thing in few minutes, how we can also now compress it further. But that's a good thing. So you can see the speed of, can you tell me also, in fact, not Karthik, anybody else, can anybody tell me why the processing speed kind of improved as soon as we moved to Avro and sequence?
Because the data compressions happened, so the data types got changed and the processing speed has changed.
Okay. Anybody else who got some result?
Yes, Shivank. Like I imported like Avro file, it took 7.5 MB, but time is 31.77. Sequence, it's same. There is no changes in data size, but time is very less, like 19.6 seconds.
Perfect. But what about Avro?
Yeah, Avro 31.7 seconds.
Avro remains the same. Okay.
Yeah.
X was also 31.
Yes.
Anybody else who have tried on some different table? What about you, Gayatri? Aditi, what about you?
I did try, but I'm getting a lot of difference between Avro. Like I don't know why, because like for sequence it showed 21 MB and for average showing 44 MB. So I'm thinking of running it again.
You can try.
Sorry.
You can try a different table also once.
Yeah.
Actually, this cluster is not very reliable because it's a very small cluster and the data set is also not that huge, which we are using right now.
You tell because of the cluster not being that stable, we get this much difference, and a lot of us are trying to access it.
So right now on the same cluster which you are using, there are multiple people who might be using it, not just in this class, but even outside, because this cluster is being used by a lot many people around. And they have created a cluster with just 3 machines. So what happens is if your name node got busy, what happens is like definitely the mapper and you have to still send the mapper code, right? If it maybe at the time when you hit it and a lot of other requests are also in the queue, then your job ID could get a little delayed. Means in terms of processing time, yes, it will have an impact. And because of the data size, if we take like some GBs of data or something, you will see a good difference in the size also coming up. But we are using GBs or MBs of data. Okay, now one thing I want you guys to also add. Just add hyphen compress in your statements for Avro, for sequence, for text, and now tell me the difference. Do it on different files, maybe that will be better. Maybe a best way to do it is, can you do an import all table? No, sorry, don't do import all table. It will take some other tables also, right? Okay, just do an import maybe quickly and tell me, maybe you can use message table or whatever you wish to. I leave it to you. And tell me with compress for all these three formats, what just happened. First of all, you should see .gz coming up in the, which is denotes that it's a compress format.
Shivam, can you repeat that? Compress?
So you have to just add -f in compress in your
Okay.
in text.
All right.
Hello.
Yes, ma'am.
Yes, I'm getting, means without compress, I'm getting mixed results. Means for Avro, the time, the file size is the least, but time taken is the maximum time.
Time taken for which one is maximum?
Avro. But the file size is least of all.
Okay. Can you just add compress and tell me now?
Okay.
Yeah, Shivank, I have done for this recipient info table. For this recipient info table for text file, I have got 1.2 MB size. Like previously it was 6.9 and it got compressed to 1.2 and within 21 seconds. And for this Avro file, it got compressed to 1.23 MB within 39 seconds. And for sequence, 1.67 MB within 42 seconds.
Okay. You have used hyphen compress.
Yes, I can compress.
Okay. Okay.
So Shivank, after compressing,
Mhm.
um, I got almost for all the files 4 times lesser, size of the files. Earlier it was around 16 MB for all the files. Now it's coming 4.2, 4.3, and 4.7 respectively for text, sequence, and Avro. At the same time, there is a drastic decrease in data transfer rate also. Earlier it was around 600 kbps. Now it's around 135 on an average. And also the time is it is taking more time for each file, like in comparison to without compress.
Perfect. This is what exactly I was looking for. This is the right explanation of things. So with sequence and Avro, you should see a huge difference. If you're not able to see sort of an immediate thing, which may be because of the reason when you might be having a cluster which is very small and even the size of the file we are using is less, it could happen in one or two instances like that. But otherwise, in general, you will save really a good amount of cost as well. And basically, because you are storing it in the format which can be easily parallelizable also. So it's right now you have just seen from the mapper portion that it's able to bring it quicker. But at the same time, when you will start processing it further, you will find it even your processing to be far better as well. For example, you will be seeing Apache Spark, we will be using Parquet formats and all that as well, which is also in similar nature. We will talk about that later. But you will find that the processing speed sort of improves drastically when we use this. So these things you have to keep in mind when basically you're going with your optimization. So last 2 minutes, everyone just complete this exercise and then we will move to the next topic. If anybody else also finds something similar to Karthik, let me know. So Karthik, which file you have used for it? Karthik?
I have used reference info table.
Okay. Okay, so everyone clear now on this? So if you have not yet complete, you can do it later also, guys, because we have to still finish few more topics in today's session. The time I have allocated for this was around 1.5 hours, which we did. Everyone clear on this part? How with respect to now optimizations, we have to also think of all the compression techniques, looking at the number of mappers, also understanding what's the problem like null data problems, issues and all, how to rectify that. Now, it doesn't mean that I have covered everything. There still could be some other problem, but I just gave you a reference that what kind of things can come up and what you can at least keep on top of your mind while starting your job. Not just directly using your scoop commands and directly importing, that will not help you. Any questions on this?
What is the default format for a scoop, Shivank?
It's a text file, right? That's what we were seeing till now, that whenever we were transferring to scoop, it was just blindly going and storing like a text file for us. Any other question? Okay. So there were three things which are left out. One was the job. Second was we have also missed out on Hadoop 1.x and Hadoop 2.x architecture, which was related to yarn architecture. So let's start on them and we will finish them one by one. That what are the things we missed out in yesterday's session. So number one to start with, I'm going to start with Hadoop 1.x. Guys, I need your attention now. If you have not yet completed, you can do it later. If you have any questions, we can again go over it tomorrow. So the first thing in Hadoop 1.x is the way it works. There will be a client which will be sending the request, just like how we have seen into the other way in SDFS as well. Now here we will be having a different thing. Like there could be a machine where I will be having a master Java process, which we call it as job tracker. So just like we had the name node Java process sitting in the master machine, similar way, we will be having a job tracker sitting into master machine. Now, one thing here, this job tracker could be either sitting along with the name node also in one machine, or they could be in separate machines also. It's completely have no difference with that. Now, what happens is the first step. First step would be like the client will say, hey, I want to run this, some sort of command. So what it will say, it will go and request to the master node. The master node will not basically go to the name node JVM, but it will be looking for the job tracker. So it will say, hey, give me the job ID. So it needs a job ID for it. Once it goes to there in job tracker, what job tracker will do, at the master machine level itself, it will check from the name node that all the permissions are okay with it, whether the client who is requesting have the appropriate permission, input path is correct, output path is correct, everything it will justify. Once it will verify, then further to that, it will say, hey, fine, take this job ID. So it will give a job ID back and will say, hey, go ahead. Now the client, what it will do, it will at an SDFS location, it will store all the details related to that job. Okay. At the SDFS location, it will store all the details related to a job. There's a shared location which will be configured at the time of installation. And all the details like what's the input path, output path, like where all the things are residing, everything will be basically coming back along with this. So what we are doing, we are saying that copy your job resources. Now what's going to happen? It will say, hey, I've saved it. And then it will go ahead and inform that, hey, I've done. Now please submit my job. So it will return back and say, please submit my job. So now only the job will be in the submitted mode. Okay. So till now, the job is not submitted. So it will say start the job kind of instruction. Now this job tracker will queue it. There will be a queue with itself because there will be a lot of different clients requesting for it in parallel. So it will queue it. And then what it will do, it will say, hey, okay, it will basically go and talk with this to get the details of the input. First thing, like receiving all the input details and about the jobs, what the details are there. It will go and interact with the name node, collect all the information, what is required. It will decide that how many resources I need for it to run it, like where all should be, I should be sending the mapper code, where I should be sending the reducer code. All these things it will take a call. And then at the data node machine level, we will have another process which we call it as task tracker. Now what this task tracker do? This task tracker is going to continuously keep informing the job tracker, hey, I'm alive, sort of sending the heartbeat. So that way the job tracker will have an idea that yes, this task tracker is alive, this machine is okay. Now, once it will get it, it will return back. Basically, job tracker will return back in the form of instruction. It will say, hey, I have a task for you. I know that you have basically this file presented with you. Can you go ahead and submit basically a task? It will say, hey, take this task and complete it. Now, it's not just to this machine because data nodes could be multiple, right? So like there will be task tracker here also. So maybe one job is divided, like mapper code can go to 2 different machines also, right? So maybe this is also sending the heartbeat. So it will also respond back to it that, hey, this is a task for you. This is a task for you. Go ahead and complete that for me. So this way, once it will be going to the task tracker, again, this task tracker will go and collect all the information from here, whatever it needs once the job is given to it. Then it will just go ahead and launch your MapReduce job. Whatever it's coming in from the job tracker will execute it. And once everything is over, it will return back the results. And again, the job tracker will return back everything to the client. This is the process what your Hadoop 1.x follow. Again, repeating, client is going to say that, hey, submit my job. It will ask for a job ID. Master machine, which is a job tracker, will request and verify whether everything is okay. Once everything is okay, it will give back a job ID number. Then the client is going to copy all the job resources to your SDFS, a common shared location. Once it is done, it will say, hey, submit my job, start my job. Once it is done, job tracker will come back and again connect and get all the details about input split, all the details. It will also connect with the name node, collect all the information, decide that where it had to schedule. It will also monitor the job, everything it will do. Then it will inform the task tracker that, hey, you are the task tracker. I got to receive a heartbeat from you, means you are alive. Can you go ahead and take this task and complete this? Once this is done, then task tracker will collect the information from this location again. And once it collects all the information, it will go ahead and execute the MapReduce job, because there might be some configuration settings also here. So those configuration settings will also it have to collect. So now once all this is done, it will submit the MapReduce job for me. Now, so this is the whole scenario of Hadoop 1.x. Can you tell me what is the problem you notice in this approach?
There's going to be more load on the HDFS common.
Overload on what?
Because every other node or every other point is trying to connect with the, what do you call this, HDFS common storage? What do you call it?
Existing common storage is okay. That don't take time.
There will be more communications. It took more time.
Communication takes more time. Okay. Anything major you can see in this?
And there is no backup for job tracker.
Very good. So that's the correct point, that there is no backup for it. This is the only it can act like a single point of failure. Anything else? In fact, I should say in your Hadoop 1 context, I have only one name node and we have secondary name node, which is anyway cannot be a backup. So master level itself means even if you talk with respect to name node also, it's a problem. But that's a correct answer. Any other answer? Can you guys notice one thing? We are overburdening the job tracker. Agreed, everyone? We are overburdening the job tracker because job tracker is responsible for job scheduling, your resource management, your job monitoring. Everything is done by job tracker itself. So this is going to be an overburden because you are asking everything to be kind of given the responsibility to a single job tracker. That's one of the major drawback actually. And due to this, you can only scale your cluster in Hadoop 1.x till only 4,000 nodes. You cannot have more than that. So scalability beyond that was not feasible in Hadoop 1.x. And second thing was in Hadoop 1.x, you can only run your MR job. You cannot do anything else other than this. So it was also a big problem with this. First of all, everyone clear with this? What are the issues with it and how we have went ahead and solved it?
So Shiva, what's the component that receives so that's communicating with the client where you said copy job resources? Like what is that component called?
Basically this part, this is a
Yeah.
application. You can think of it in your configuration. If you go, you can check there is something like /temp, something is configured there. So that's where we keep all the temporary resources. Once this whole thing is complete, you can go ahead and remove it. It will basically remove that. Clear on this part? Any other question? Okay. Now let's talk about Yarn, which is Hadoop 2.x, how this works. Again, it will follow the same model. I have a client. I have a master machine. Now I'm just changing this master job tracker to resource manager. Let's give it a new name to it. Resource manager. Okay. Here I will have node manager. Task tracker will become node manager. Node manager. Okay. So again, the same thing will start. The client will request for it a job ID. It will verify. It will return back a job ID. It will go ahead and store it in a location. Once it is done, it will go and say that submit my job. This part is similar. After that, a change happens. What is that? The first thing is, let me recall you your school days. Is there anyone in this class who used to be a class monitor in your school? Class monitor? No one?
Yeah, I have been monitored once or twice.
Okay. So what was the responsibility? Making the other students quiet, right? You were only doing that, like kind of helping.
Yes, like in between, yeah, in between periods, there is no noise until the teacher comes and something like.
Correct. So you kind of were helping the teacher also, right? In a way, like you were sort of an assistant to the teacher, not just keeping the maybe the style, but maybe if there's any assignment, collect all the homework copies from everyone, give it back, right? All those things you were doing it up. But were you having any kind of power that, hey, I want to rusticate the student because I don't like it? Can you do that? You can go and recommend to the teacher, but you cannot do that. You can only say, hey, basically this student make a lot of noise and let the teacher take the call. Similar way, there is something called as application manager here or application master here. So what happens is this resource manager will allocate any one of the node manager to be starting an application master. Okay. So think of it like a class monitor. Now what this will do, this application master is too specific to a job. Okay, so every other job will have its own application master. So now this application master will go here, will talk to the name node, will be responsible for basically ensuring that how much resource it needs. It will do the calculation that how much resources I basically need for this particular job. And once it will complete this job, then it will go and ask resource manager, hey, I need this much of resources. Now, when I say this much of resources, it could be something like, hey, in my data node 1, I need 2 GB of RAM. I need 2 CPU. In data node 2, I need 3 GB of RAM and I need maybe 4 CPU. Like this. It will request for it. Now, resource manager, once it have it, because it may happen that all the resources are busy, but once it has it, it will say, hey, I'm granting you. Now it will say, go ahead and you have permission on the data node 1 to use this much. So what happens is this thing comes like a container. So let's say this is my data node 1 itself, and this is my data node 2. So now this will come like a container. So in your RAM, think of it, you're getting a permission that for this task, you can only use this much of space. This much of space. You can use only 2 GB of RAM, 2 CPU. You're not allowed to use more than that. So kind of you're getting a box, sort of a container, or you can say the permission to use this much of space of your memory or your CPU to kind of go ahead with that. Once you complete the work, application master will be kind of collecting all the output back and then will return basically the results to the resource manager. This is a small change which have brought the huge difference in terms of cluster size, performance, and everything. Let me show you how. Earlier, what was happening? This job tracker, so let's say it got the job ID J1, then it got the job ID J2. For every job, you have to do the same task. Now what happened? Because you allocated something like a class monitor. So maybe for one client, this you got one application master, let's say AM1, right? Maybe there's another job which this client hit or another client hit. Maybe you will create another application master, maybe on some other machines, which is free, right? On this application master will be going and talking and will be responsible for doing that. So AM1 and AM2 can work in parallel also now. So earlier, job tracker was the only one who was like doing for first J1, then it was going to J2, then it was going to J3. It was a sequential access. But now, because I could have like thousands of data nodes and I'm doing this on the slave machine now. So now since I'm giving this responsibility to like a class monitor, you can think of. So for every data node, there could be one class monitor at a time. So if I have 1,000 data nodes machine with me, then I could have thousands of job computations happening in parallel in that case, right? So this gives me more flexibility now to increase my work, because for every job now we are making the slave machine responsible to do all that task for me, which is we are doing it with the help of application master job. And then this container is helping me to kind of making sure that, okay, if in, let's say one of the data node, let's say I have 8 GB RAM, maybe 8 CPU. So maybe I would say, hey, I'm just allowing for job one, I'm giving you maybe 2 GB RAM and maybe 2 CPU. Then further to that, maybe there could be a job ID 2 for which I could say, hey, you can use now 6 GB. Maybe you can use 5 CPU like this, right? So we are able to, even because of this container concept also, we are able to very well distribute now. So now it makes the resource manager job little more easier to allocate the resources as well. Everyone clear on this? How this concept in Hadoop 2.x made an impact by just a small change, if you notice. It's a very smart and a small change, what they did. Any question on this? We can take a minute to grasp this concept.
Hey, Shivank, can you go back to the previous page?
Yeah, please.
No, I mean the last one where you allocated 8 GB of RAM, 8 CPUs, right? So this 8 GB and 8 CPU, that is allocated by the master node.
Yeah, so think of it, let's say this is one data node, which is, let's say, a laptop, right? Now in this laptop, you could have 8 GB of RAM and maybe 8 CPU, correct? These are like codes. I should not call it CPU, I should call it codes. So now this is a code. Now your resource manager will be having this detail that this machine will be having this much, right? So now when it is allocating, once the application master will say, hey, I need basically 2 GB of RAM and 2 GB of CPU in data node 1, then it will go and check. Maybe this process is already running. So now 6 GB of RAM and 5 CPU are occupied, which means 2 GB is left and 3 CPUs are also left. So will I be able to provide that access? Yes, because of a container part. Because every container request is already being stored as a metadata with it. So it will have the knowledge that, okay, how much busy the other machine is. You got the idea now, Aditi?
So,
oh, sorry.
So the master node will have information about all the slave nodes, how much they are occupied. Is that what you're saying?
Yes.
Okay. And what happens if one of the slave nodes, it is running out of all these capacity and memory, can it further request for more resources in that case?
You can go and upgrade your existing resource. That's number one you can do. But in case if it's still you not having it, then your job will go out of queue. Means it will stay in queue and wait till the time the other, it will get the resources, it will wait. But resource manager is smart, or application master when it's take a call is smart. What it do is it basically tells that, okay, I need this much of resources, but it will be sort of negotiating with the RM also, right? That what is the there. So maybe the replica copy of the same block is sitting in some other machine also. So from that, it will quickly go ahead and say that, hey, this machine have this replica copy, send it to this machine.
Okay.
So if it like say it will try it, let's say 3 times. I think the trial happens for 3 times. If it fails for all the 3 times, then in that case, it will go ahead and again recompute and request again for that.
Understood.
Any other question from anyone?
So, so the data node has the application master, right? Shiva, so
I should not call it actually data node named habit, because data node is actually nothing but a JVM process. So you can say the slave machine habit. Yes.
can you say that again?
So we should say slave machine habit, because data node is also a Java process, right? Just like
Right.
application master is also.
So is it optional to have application master, or it needs to have it?
The application master will always run in Hadoop 2.x. That's an architecture.
I mean, I'm asking, does each node has to have it, or is it optional on, I mean.
No, so not, so let's say I have a cluster of, let's say 3 size. Okay. Now in this case, maybe I have only one job. So maybe in this case, this RM will decide that maybe one application master is running here. Maybe there's another job coming in, J2. Then in that case, it can say that application master is running here. But let's say there's no job right now, J3. So this can stay free.
So yeah, it'll spin up it based on the requirement, I guess.
Correct. So let's say once AM job will be over, then our RM will immediately know that this machine don't have it. So maybe J3 comes in, maybe it can allocate it, this application master to this machine or this machine, any one of it.
Okay, so it'll choose which, it'll pick which node to spun the this thing, application master, based on the availability of the resources.
Correct, correct. Any other question from anyone? So I hope everyone is clear now. Okay, I couldn't complete the scoop job part, guys. So maybe that I can bring it up tomorrow. But we were able to complete these 2 components, which were missing out actually from last class. So I will start tomorrow with the basically scoop jobs. And once we are done with this, then we will be moving to another topic called as Apache Hive. Scoop job will take just 5 minutes anyway. So then after that, I will execute the Apache Hive and we will finish it. Okay. So this is it for today then. Thank you, everyone.
Thanks, Shiva. Thanks, everyone.
Thank you, Shivang.
Thanks, Shivam. Thank you.
Thank you, Shivang.
Thank you.